Multiplying radicals is probably the easiest operation that we can do with radicals. We're just using our actually simplifying rule backwards. We saw the other day that the rule that we use to simplify radicals is if you're taking the root of two things multiplied together, then you can do the root of each factor. Well, our rule for multiplying radicals is actually just this written backwards. So if you're multiplying two radicals together, all you really do is just multiply the stuff underneath. Now there's a few things we got to watch out for. Now of course this rule is only true if the index here is exactly the same, right? So you can't, well, we haven't learned how to do it yet, but we couldn't do like the square root times the cubed root using this rule. And there's one more slight little subtle thing that you may not see in your textbook. This only holds true if both a and b aren't both negative. Now that's not going to be a problem for us in this chapter, but it is something to watch out for in the future. So really all we're going to do, as long as it has the same root or index, we're just going to multiply the stuff underneath and then simplify. So again, we really don't have steps here, but just multiply the radicals using the rule. And step 2, simplify the radical, whatever's left over. So again, our directions here generally are just going to be simplify. So if we're given an expression kind of like this, let's say the square root of 4x times the square root of 8x squared. All right, by looking at this, we can see they are both square roots and we are multiplying them together, which means we can just multiply underneath. So our 4 times the 8 gives us 32. X times x squared gives us x cubed. Once you multiply them, then see if you can simplify the radical. So there is a perfect square in 32. It would be 16, so that's 2 times 16, x cubed. All right, let's see what comes out of this radical. I don't know what the square root of 2 is. The square root of 16 is a 4, so we can have a 4 come out. And since the power is bigger than the root or the index, we can bring out some x's. 2 goes into 3 once with 1 left over. All right, so all we did was, since we had the same root or index, we multiplied underneath and simplified our radical. So let's try it out. Let's make it a little bit harder. What if I said 2x cubed root of 5x to the 4th times 3 cubed root of 8x squared. Okay, so a little bit different here. The idea is, since we have stuff on the outside and stuff on the inside, we're going to multiply the stuff together that we can. So the stuff on the outside, we have a 2x times a 3, that's going to give me a 6x. Since both of those are cubed roots, we can just multiply underneath. So 5 times 8 is 40. X to the 4th times x squared is x to the 6th. Now you want to try to simplify this radical. Are there any perfect cubes in 40? Yeah, it's 8. So we're kind of going backwards there. All right, so let's see what comes out of this radical. Don't know what the cubed root of 5 is off the top of my head. Cubed root of 8 is 2. When that comes out, 2 times 6 is 12. All right, I can bring out some x's because the power is bigger than the root. 3 goes into 6 twice, so I can bring out an x squared. There's already an x out there, so that gives me an x cubed. 3 goes into 6 twice with none left over. So we end up with 2x cubed times the cubed root of 5. All right, so as you see, it's very, very straightforward. Just multiply this stuff on the outside together, the stuff on the inside together, as long as it's the same radical, and then use our old rules to simplify the expression. All right, let me give you one of these to try real quick. Let me get us a little bit more room here. So this one's going to be yours. Let's see, how about 4x squared, square root of 6x cubed. And let's do 2x square root of 4x to the 4th. All right, 4x squared times the square root of 6x cubed times 2x. square root of 4x to the fourth. All right, hit pause and see if you can simplify this. All right, you're back. Let's see what we're doing. So all of this is multiplication. Notice we don't have any addition or subtraction, so you just multiply the stuff that you can. The stuff on the outside, I have a 4x squared times a 2x. That gives me 8x cubed. Since both of those are square roots, we can just multiply on the inside. 6 times 4 gives me 24. X cubed times x to the fourth would be x to the seventh. Multiplying, you have like bases, you add those exponents. All right, now let's see if we can simplify this radical. Are there any perfect squares in 24? Again, it's 4. All right, let's see what we can simplify then. So I know what the square root of 4 is, that's 2. When the 2 comes out and multiplies what's out front, that gives me a 16. The square root of 6, don't know what that is. Since the power on the x on the inside is bigger than the root or the index, we can bring some out. So let's see, 2 goes into 7 3 times. So x cubed can come out. X cubed times x cubed would be x to the 6th. So 2 goes into 7 3 times with 1 left over. So you should have ended up with 16x to the 6th times the square root of 6x. All right, one more little wrinkle that they're generally going to add in here is just throw the distributive property in on you. So if I look like the square root of 2x, square root of 6x minus the square root of 8. All right, now notice the slight difference here is we do have addition or subtraction involved. Well, that's really not going to change that much. All that's really going to change it here is that we actually have to use our distributive property when we're multiplying. Now, since everything's square roots here, this should work out just fine. So for the first one, we just multiply underneath. That gives me 12x squared minus the square root of 16x. Now we need to simplify each one of these radicals before we can decide if we can add or subtract them, because remember, to add or subtract, they have to be like terms. The perfect square in 12 would be 4, so that's 3 times 4, x squared, minus, and well, 16 itself is a perfect square. We'll wait one more step. So here, let's see, what can come out? 3, I don't know what that square root of 3 is. The square root of 4 is 2. And let's see, I can bring out an x. 2 goes into 2 once with none left over. Minus, let's see, what can we do here? The square root of 16 is 4. And I don't have enough x's to come out. Okay, so are these like terms? Let's see, these are x square roots of 3, and these are just square roots of x. So those are not the same things, which means we cannot combine those like terms. So multiplying radicals is very straightforward. As long as they have the same root or index, kind of like here was a square root, you just multiply underneath and simplify your radicals. If you do have stuff on the outside, just multiply the stuff on the outside together as well.